Hello everyone, welcome back to the channel. So now that we have seen the different types of data and levels of measurement, so we are ready to explore different graphs and tables which will allow us to visually represent the data we are working with. So visualizing the data is the most intuitive way to interpret it. So it's an invaluable skill. So it is much easier to visualize data if you know its types and measurement level. As you may recall from, there are two types of variables, categorical and numerical. So in this video, first we will focus on categorical variables. So some of the common ways to visualize them are frequency distribution table, bar charts, which is also known as a column charts, then the pie charts and the Pareto diagram. So first let's see what a frequency distribution table look like. It has two columns. Now you can see that the category itself and the corresponding frequency. Category here is the Audi, BMW and Mercedes. So as we have already discussed, categorical data are those data which can be grouped also. So Audi cars can be grouped into Audi group, BMW cars can be grouped into a BMW group, and Mercedes car can be grouped into a Mercedes group. So anything which can be grouped or where answer to the question is yes or no, that is known as a categorical data or a categorical variable. So imagine you own a car shop and you sell only German cars. So the table shows that category of cars. So graph on Excel can see that Audi, BMW and Mercedes and their frequency, or in plain English the number of units sold. So by organizing your data in this way, you can compare the different brands and see that Audi has been sold the most. So that is a frequency distribution table which is very easy to interpret and analyze. Now you can distribute your data in a frequency distribution table for a categorical data. So the next type of a chart is a bar chart, which is also known as a column chart. Now you can see that using the same table which we used for a frequency distribution table, we can construct a bar chart, and it is also known as a column chart. The vertical axis which you can see over here, these are the vertical axis. The vertical axis shows the number of units sold. So each bar represents a different category indicating on the horizontal axis. So in this way, it is much easier and much clearer that Audi is the best selling car brand. Now the next chart for a representation of a categorical data is a pie chart. So let's represent the same data as a pie chart. So now in order to build one, we need to calculate what percentage of the total each brand represents. Now you can see this pie chart on Excel. So in statistics, this is known as a relative frequency, means we need to calculate what percentage of the total brand represents. Naturally, all relative frequency adds up to 100%. Pie charts are especially useful when we want to compare items with each other. See each item's share of the total. So this example could be easily transformed into a business example of a market share. So market share is predominantly representing by a pie chart, that if you search for a market share in Google Images, you would probably will get a pie chart only. So imagine that data in our table represent the sales of Audi, BMW and Mercedes in a single graph. Now this chart will show us the market share that each of this brand has. Now you can see in the diagram we have Mercedes market share of 34%, Audi 37% and BMW 29%. Lastly, we have the Pareto diagram. In fact, Pareto diagram is nothing more than a special type of a bar chart. I repeat, Pareto diagram is nothing more than a special type of a bar chart where categories are shown in descending order of frequencies. Now you can see over here, this is a Pareto chart over here, means by frequency, statistician means the number of occurrence of each item. So as we have said earlier in our example, that's exactly the number of units sold. So creating a Pareto diagram, let's go back to our frequency distribution table and order the brands by frequency. Now we have already ordered that the Audi sale is 124, Mercedes 113 and 98. So we have ordered and we have sorted that thing, okay, in a descending order. So there is one last test to make it one. A curve on the same graph shows the cumulative frequency. The cumulative frequency is the sum of the relative frequencies. It starts with the frequency of the first brand. So the polygonal line is measured by a different vertical axis on the right of the graph. So at each of its vertices, it shows that subtotal of the categories by itself. So the Pareto graph or Pareto diagram combines the strong sides of both the bar charts and the pie chart. So it is easy to compare the data between categories as a part of total. So further, it was a market share graph. Then you could easily see the market share of the top 2 or top 5 companies. Now in this Pareto diagram, you can see that market share of top 2 companies. Now if I see a market share of top 3 companies, now it is 100%. Now if you want to see a market share of top 2 companies, now you can see that this graph, so it is almost around 70% or 75%. So market share can represent in this way also. So furthermore, it was the market share graph. You could easily see the market share of the top 2 or top 5 companies. But the Pareto principle, there is a Pareto principle. Finally, the Pareto diagram is named after Vilfredo Pareto. You may have heard of another idea of his, the Pareto principle, also known as the 80-20 rule. So it states that 80% of the effects come from the 20% of the causes. So in a real life example, we can say that there is a company, Microsoft. They say that if you are going to fix 20% of your software bugs, they manage to solve the 80% of the problems of the customer experience. So in a similar fashion, a Pareto diagram can reveal the information like that. So it is designed to show you how subtotal changes with the additional category and provide us with the better understanding of our data. So far we have covered frequency distribution table, bar charts and pie charts and the Pareto diagram. So the categorical data can be represented either in a frequency distribution table or a bar chart or a pie chart or a Pareto diagram. So each visualization serves a different purpose. So frequency distribution table organize categories and their frequencies. Bar chart makes category comparison easier, and pie chart shows each category shares of the total. And Pareto diagram, it combines category comparison with the cumulative frequency analysis. So now let's talk about visualizing the numerical data. So we have already know that how to create a graphs and tables for category variables. So now we are going to do the same thing for the numerical variables as well. So given that numerical data is the main focus of this course, we will spend a couple of lessons or couple of hours on numerical data only. So whenever we want to plot a data, it is better to first organize it into a table. So numerical data, the first approach should be organize that data into a table. So whatever we did in the categorical variables as well. Let's start by creating a frequency distribution table. You can see on the graph, here is a list of 20 different numbers. If we arrange them in a frequency table like the one we used for a categorical variables, we would obtain a table with 20 rows, each representing one number with a corresponding frequency of 1. Since each number occurs exactly once, so this table would be impractical for analysis. So that is not going to solve our purpose. So grouping data into, so what we can do, we can group the data into the intervals. So when we deal with the numerical variables, it makes much more sense to group the data into intervals and then find the corresponding frequencies. So in this way, we can create a summary of the data that allows for a meaningful visual representation. So now the question arises, how to choose the interval? So how do we choose the interval? Generally, statisticians prefer working with a group of data that contains 5 to 20 intervals. It is not necessary, but it is advisable that 5 to 20 intervals. So this way the summary remains useful. However, the correct choice of interval varies from case to case and largely depends on amount of data we are working with. So in our example, we will divide the data into 5 interval of equal length. Now the question arises, how we are going to calculate the width. So a simple formula here we have used. Now you can see that largest number in our data is 100. Now you can see that largest number is 100 and the smallest number is 1. Okay, so now number of intervals I want, we have decided that we want only 5 intervals. So what I can do, I can minus largest number, which is 100, 100 minus 1 smallest number, and divided by 5. So it will come approx 19.8. So we can round this number up to obtain a neat representation. So therefore our interval becomes 1 to 21. So now you can see that my first interval starts with 1 to 21. Now how many numbers are occurring between 1 to 21? I can count that. Okay, so there are two numbers which is coming between 1 to 21, and then we have a 21 to 41, 41 to 61, 61 to 81, 81 to 101. Now what I have done, I have created a 5 equal intervals. So each interval's width is 20. So constructing the frequency distribution table. So let's construct the frequency distribution table. So a number is included in a particular interval if it is the greater than the lower bound and it is equal or less than the upper bound. Say for example, if some number comes 21, so now that number will fall in this 1 to 21 only. Okay, it will count from 1 and 21. If it is a 22, then it will go to this second interval. So that is, the number is included in a particular interval if it is greater than the lower bound and it is equal to or less than equal to the upper bound. So here upper bound is 21 and lower bound is 1. So from the table we can see that interval frequencies. Now we have also calculated the relative frequency over here. Now you can see that for many analysis it is useful to calculate the relative frequency of the data point in each interval. As discussed in the previous sessions also, relative frequency is the frequency of a given interval as a proportion of the total. Okay, proportion of the total. Let's add another column to our table called relative frequency. So I have did this, I have added the relative frequencies. Now the interval 1 to 21 has absolute frequency of 2. Now it has the absolute of 2 frequency. How many numbers are coming between 1 to 121? That is 2. Now you can see that how many numbers are coming between 1 to 21. Okay, there are 2. And in total we have 20 observation. Now you can see that we have a total 20 observation. Now 2 is what percentage of 20? So if I divide 2 divided by 20, okay, so it will come approx 10. So 10%. So that is why I have written here 0.10. In a similar fashion, 4 is what percentage of 20? So this is a relative frequency 20. It will come around 20%. So I can write 20% as 0.20. So we are calculating the relative frequency, means what is the total market share. Just we have seen an example in the previous sessions also. We repeat the same calculation for every interval each the table is complete. So means now we have calculated for the frequency of 0.15 in a similar way. We have calculated for the 61 to 81 in a similar way. So we have calculated the relative frequencies for all these things. Okay, so total of this is 20 and this is what a numerical. So key takeaway from numerical data is best summarized by grouping observation into intervals. So remember this thing, numerical data can be best summarized by grouping observation into intervals. So frequency distribution tables for numerical data are more practical than listing every individual value. So that will not, here it will not make any sense listing each in this way. It will not make any sense. So statisticians typically use 5 to 20 intervals depending on the size of the data sets, and interval width is calculated using largest value minus smallest value divided by the number of intervals you want. So in this also we have used the largest value was 100, smallest value was 1, and we wish to have how many intervals? 5 intervals. So I decided to go with the interval of 19.5. So I have rounded to the 20. So I want the equal interval of 20. So that is the reason I use 1 to 21 and 21 to 41. So the width size is 20 in each thing. So equal interval. So absolute frequency is the number of observation in each interval and relative frequency is the proportion. So this is your absolute frequency, this one. 2, 4. How many times, how many numbers are between 1 to 21? So absolute frequency, absolutely. 41 to 61, 3 numbers. 61 to 81, 6 numbers. And 81 to 101, there are 5 numbers. So this is something we have to see. Now the next chart we will see is a histogram. So histogram is also generally used for the visualizing the numerical data. So the most common graph used to represent numerical data is the histogram. So first we will learn how to create it and then we will describe the way that data is represented. So we are going to use a different frequency table from our previous example to help us out. So first I will decide what is a histogram. As you can see, histograms look similar, okay, similar to a bar chart, but it is actually conveys a different information. Now what is that different information? Like a bar chart, the vertical axis is numerical and shows the absolute frequency. Now you can see that there are only two numbers between 1 to 121. So this we have seen in the previous example also, and between 21 to 41 there are approx 4 numbers. So it looks like a bar chart. The vertical axis is numerical and shows the absolute frequency. However, unlike a bar chart, the horizontal axis is also numerical. Now you can see that horizontal axis means this axis. This is horizontal and this is vertical. The horizontal axis is also numerical. So what are the components of a histogram? Each bar has width. Now you can see that each bar over here has a width. So this is the width. Each bar, this bar has a width, this bar has a width. Each bar is represents a width. Height is equal to the frequency, means absolute frequency. How many numbers are between 21 to this thing, okay. And notice how the different bars are touching each other. The bars are also touching each other. This is to show that there is continuity between the intervals. So this is to show that there is a continuity between the intervals. Each interval ends exactly where the next one begins. So in the bar chart, different bars represent different categories, so the bars are completely separate. Now on the right side you can see the histogram, okay. So histogram using relative frequency, sometimes it is useful to plot the intervals against the relative frequency instead of the absolute frequency. Now here you can see that I am not using the absolute frequency, I have used the relative frequencies. So visually the histogram looks exactly the same, but it provides different information to the audience. Remember, relative frequency is expressed as percentage. So there is no way to do that in Excel, but it is useful concept to understand. So histograms with unequal intervals. So there is one last thing to note. We may create histogram with unequal intervals as well. Now we'll talk about histogram with unequal intervals. So histogram with unequal intervals and where it is been in the real life. So you would likely completed the survey where you were asked about your age. So with the options you got options of age of between 18 to 25, now 26 to 30, 31 to 35 and 60 plus. So these are what? These are unequal intervals. Now what happen in unequal intervals? Clearly the intervals will vary. These intervals reflect different focus group for the experiment and usually have a specific reason behind their design. Say for example, young adults under 25 may not be able to afford the product. Now this is a group which is not able to afford. This group cannot afford your product. Okay, so less than 25 years age people are not able to afford your product because of specific reasons. So adults over 60 may have little or no interest. Now this is the area, the people who are having an age of 60 plus, they have no interest, okay, or they have very little interest. They don't want this product to be used. So in any case, you should be quite experienced before accurately designing the interpreting such groups. So it is highly recommended that you stick with the equal width interval until you gain enough experience. So the key takeaway from the session today is that a histogram is the most common graph for representing a numerical data. It is created using a frequency distribution table only. The vertical axis represents a frequency, the horizontal axis represents the numerical intervals. Bar touches each because intervals are continuous. So histogram is the most common way, means most common graph for representing a numerical data. Say for example, you have a numerical data, and numerical data can be represented in this way. Now let's talk about representing the relationship between two variables. So far we have covered graphs and that represents only one variable, but we have to represent relationship between two variables as well. Cross table, which is also known as coincidency table. Let's start with categorical way. The most common way to represent them is using a cross table, or some situation call them contingency table as well. Now you can, on the left side you can see the cross table. Imagine you are an investment manager. You manage stocks, you manage bonds, you manage real estates. So for three different investors, each investor has a different attitude toward a risk. So their money is allocated differently among the three asset classes. So you can clearly see rows showing the type of investment and columns showing the investor's allocation. So it is good practice to calculate the total of each row and column, as they are often useful for further analysis. Now you can see that row total, the total row total gives us the total investment in stocks, bonds and in real estates. So you can see that column totals, the column total gives us the total holdings of each investor. So we can also use a side by side chart also. So once we have created a cross table, so now we have created a cross table. Now you people understand the use of this cross table as well. Now you can see on the side by side bar chart. So once we have created a cross table, then we can visualize the data. A very useful chart in such case is a variation of the bar chart called the side by chart. It represents the holding each investor in different asset classes. For example, stocks are shown in green, bonds are shown in red, and real estate is shown in blue color. So the name comes from the fact that for the investor, the asset categories are represented side by side. So this makes it easy to compare asset holding for a specific investor, asset holding for a different investor. So that is quite easy. So all graphs becomes easy for to create and interpret once you have identified the type of data and choose the appropriate visualization technique. We are going to talk about the scatter plot. So finally we come to a very important graph, that is a scatter plot. A scatter plot is used to represent two numerical variables. Example, for this example we have gathered the readings and writing of SAT score of 100 students. So let us examine the graph before we analyze it. Understanding the scatter plot, the score range, stat scores for each component range from 200 to 800 points. 200 to 800 points. That is why the graph is bounded with this range. Axis, horizontal axis represents, this horizontal axis represents reading scores, vertical axis represents the writing scores. So data points, so there are 100 data points and each student's result corresponding to 1 point on the graph. So each point provides information about a particular student's performance. For example, this is Jane. Okay, this is a Jane. She scored in writing, she has scored 300, and reading she has scored 550. So interpreting, now you can see that how many she has scored in the reading, how many she has scored in the writing. So in this way we can use scatter plot. Scatter plot usually contains many observations. When interpreting a scatter plot, a statistician is not expected to focus on individual data points. Instead, the goal is to understand the overall distribution of the data. So observation 1 is that upward trend. The first thing we notice is obvious upward trend. Now you can see that The lower writing scores are generally associated with the lower reading scores. Higher writing scores are generally associated with the higher reading scores. Those who have got the higher in the reading, they may also got the higher in the writing as well. So this is a logical, because students who perform well in one language related tasks are likely to perform well in another. So what is the observation 2? Concentration around the center. We have also noticed that most of the data points are concentration of students is in the middle of the graph. Most scores falls in the range of 450 to 550. So this is the area where most of the chart is likely to there. Now you can see that this is the area where most of the students are getting the marks. So this is the second observation. Most scores fall in that range, and 450 to 550 in writing, and in writing also most of the people are getting 450 to 550. So since SAT score range from 200 to 800, a score of 500 is considered a average. So therefore it makes sense that many students cluster around this area. Now what is the observation 3? Now from the scatter plot, observation 3 is that high performing student. This is a group of students with both very reading and writing scores. Means exponential students tend to perform exceptionally well in both the components. So there are some students like this category, they are performing well in both the subjects, exponentially well. Okay, so this pattern is less common among lower performing students whose scores tend to vary more between different tasks. Now what is the observation 4? Observation 4 is the outlier. So say for example Jenny, she is far away from the rest of the observation. Although scored above average is reading, she has performed poorly in writing. Okay, so Jenny has performed poorly in writing. Now you can see the score of a Jenny. Okay, so this type of observation is also called an outlier because it does not follow a general pattern. Means she has performed well in one subject and she has totally performed very low in another subject. So we will learn more about outliers and how to handle them in the later on course. So the key takeaway from this session is that for a categorical variables we use cross table, contingency table, side by side charts. This help us to compare categories across different groups. But for numerical variables we use scatter plot. Scatter plots helps to identify relationship between the two numerical variables, overall trends, clusters of observation, outliers, general data distribution. Thank you very much. We'll see you in the next lecture.